Hello everybody, welcome to my week 11 video. This week's video is on the graphs we did, and to start off I'll be introducing my question, which is, if you had a rock that originally contained 750 grams of parent isotope, for an isotope parent that has 4.5 million half-life, how old is the rock if 187 grams remain? Here's just a written form of the question. It says, again, if you had a rock that originally contained 750 grams of parent isotope, for an isotope parent that has 4.5 million half-life, how old does the rock at 187.5 Gs remains? Here is like a little graph that you can go off of. I have all the titles lined up for you. I've got the information you'll need about the parent, the daughter, and the half-life there. From the given question I've given you, to see if maybe that, for what the video project has done today, is to see if you can fill out the lab based on the information I gave you and later answer the question. So it starts out with the years, the time of half-life, the proportion of the parent ratio, the daughter ratio, the amount of parent percentage, the daughter percentage, the amount of parent sum measure, and then the daughter measure. So that will be the graph you can kind of just use from here real quick and kind of go off of. So now I'm kind of, I already did my graph, so here I'm going to kind of explain like how I filled it out and to show you guys how. So I started with the age of 1,000,000 years, which the half-life is involved with that, which I have that 4.5. You always start at 0. But that kind of goes along with the second row here, so I'll move that over. And so you just multiply 4.5 by 1, 2 to get your second column, 3 to get the 13.5, and then you multiply by 4.5 by 4 to get the 18. And that is how I figured out how to get that. And then onto the proportions of the parent ratio, you should have put 1, 1.5, 1/4, 1/8, and 1/16. For that, it would be for the parent. And then as I moved on to the daughter ratio, I started with 0, then I moved to 1/2, 3/4, 7/8, and 5/16. Getting along to the percentages, you just kind of go off of what you just did in the ratios, just putting it in a percent form. So that was the one for the parent, and then you move on to the daughter as well. I have that 0 is 50, 75, 87.5, and 93.75. And then on to kind of like help out your answer here, the amount of parent, same measure. So you start with that 750 from the uranium, and you would subtract it each time by 2. You kind of go off of the ratios there. And then for the daughter measure, you do the same exact thing, except for you start out at 0, and you go up and you multiply by 2.